Good morning, everyone, and welcome to Take30, our 6-week series on Modern Analytics Framework. My name is Jeff Spear. This is week 3, and we're going to be talking about a few things today. This is the third in a series of discussing what our point of view on a modern analytics framework is like. So after giving a little bit of background on Ironside, we'll just summarize for people who have missed the earlier sessions. You're welcome to see them. There's recorded versions that we can make available if you want to go back and see them. And then we'll be talking about data sources this week. And so we're going to talk about how data got ingested sort of in older systems, sort of the old approach, and then the new approach, and doing some comparison. And then when we'll talk about data sources, data quality and data cleansing is very important. So we'll discuss that as well. And then we'll be taking questions. So if you have any questions, feel free to type them into the question window. And then we'll make sure that they get addressed. So here at Ironside, we exist to help you make better decisions about your business using your data. We have a variety of ways to do that, starting with strategic advisory, making sure that your overall roadmap, your overall approach, organizational model is set up to optimize your analytics. We also do a lot of work on the design side of things, data modeling, UX, design sprints. And then building the things that we've designed and solutioned, so data warehouses, dashboards, predictive models, and getting all those things out to production. We also do a lot of work on the governance side, master data management, which we'll be talking about today, process design, and overall sort of make sure you have the right people, process, and tools to keep your analytics running smoothly. And then managed services that lets you administer and host it. We can host things, we can just keep your systems running, so you can sort of focus more on analytics. So what we're talking about today, sort of data sources, is sort of the strategic design side, but then also a bit of governance as well. So that's sort of the focus for our discussion today. And like I said, this is week 3, talking about the what, identifying and ingesting new and existing data sources. Last week was talking about business analytic value. Next week we'll be doing knowledge worker populations, sort of understanding who is doing analytic work in your organization and what kind of work they're doing. And then week 5 will be creating a methodology for developing new insights, and then we'll bring it all together in week 6. So to summarize quickly, the modern analytics framework has 3 layers. So we just talked about generating insights, and that's what happens at the top. You've got your knowledge workers, regardless of what tools they're using and what data sources they're connecting to, are going to bring in data, they're going to ingest it, they're going to transform and integrate and create calculations and do things to generate insight. And then that insight hopefully has value. And depending on how valuable it is, they will deploy that in a variety of ways so that it can get out the organization, turn into action, and improve your business. So in order to make that deployment efficient, we want to have it automated. So at the bottom, we've got automated value delivery. So if something is of high value, you want to spend some time to make that value sort of come out automatically, get it to as many people as possible, whether that's in sort of raw data, dashboards, predictive models. And basically you've got that automated delivery separated from the insight generation. So the people who are good at insights are doing insights, and the people who are good at automation are doing automation. And that's going to be important as we see today. And then in the middle, you've got data as a service. And so you have a variety of data structures ranging from data lakes, where the data is very raw, to data warehouses, where it's very refined. But you also have structures in the middle that balance those two things of how easy is it to get data in, and how much work does it take to make it easy to get data out. So that's the overall modern analytics framework, and we're sort of talking more today about the middle part, how you get data into your data as a service structures. So this is the traditional method that you would see, and this is what you would have, and this might be all that you have. You have this nice big ETL arrow in the back, and you have your source data, and it's whether it's in files or tables or whatever. You have ETL that runs usually nightly, pulls it all out, puts it in staging tables, which is the raw data, but it's staging tables. No one's supposed to see it, no one's supposed to look at it. It's internal to the ETL process. And then you transform it. You put it into, you sort of bring different things together, you do some business calculations, you put it in the format you want it, but that's still in staging. Nobody sees it. This is internal to the big ETL process. And then you load it into a data warehouse, and that's when it becomes visible. You've got your facts and dimensions, and everything's nicely set up and ready for consumption. And so, there are lots of data warehouses and lots of organizations where this was the process. If you wanted data, you had to go to the data warehouse at the end to get it. And if you wanted to make a change, you had to go into this rather large process and make that change. So you can see it's nice and sort of coherent, but it's very monolithic. It's sort of a big process that feeds a big data warehouse. So the ingestion method in a modern analytics framework is different. It has more moving parts, and we'll talk about those moving parts. So you can see there's a lot more things going on here, right? But they're all sort of small. The arrows are small to indicate that generally these things are going to be lighter weight than a traditional data ingestion system. So you still have your source data over here in all sorts of different formats, but you're going to bring it in a few different ways. And where you're going to bring it in is to a data lake. And that's, in a way, similar to the staging area. It's even less structured than a traditional warehouse staging area, but it's accessible to people. And you might bring data in by batch. You might have data streaming in. You might use APIs so people can sort of put data in directly, or systems where you want very, very real-time data. Anytime a change happens, they call an API and the data shows up in the lake. And so from there, it's going to go to potentially a lot of different places. This is an example of how an organization might create certain data structures and move data between them. Your organization would likely have different specifics, but the concepts are the same. So here, there's another batch that takes data and brings it through to the cleansed area, where maybe you've just done some basic, cleaning up some errors that happen, doing some basic data validation rules. And this would be a subset. You wouldn't bring everything through. You would bring through the stuff that needs to be cleansed. And then there's another set of batches, one of which brings it into sort of more tabular structure. So maybe you've got, Power BI or Tableau reporting, and they want, denormalized tables. So you take the cleansed data and say, okay, here's a table with, all the orders and customer information. It makes it very easy to report on in Tableau. And so that's a subset of the data, and that happens. And then at the same time, you've got batches going through your warehouse. And again, that's a subset. You find the data that is of high value, and you send it through to the warehouse where it can be reported on. At the same time, different teams may be bringing data from all of these zones into a sandbox so they can do the types of analysis that they need to do. And so they might do that with data wrangling tools like Alteryx or Trifacta. They might write SQL scripts or other code to do it, if that's especially if they're more technically proficient. And there might be some batch loads. It might be, hey, the warehouse says, we have a really good customer dimension. Let's just put that in the sandbox every night because we know people are going to use it. Why make them go get it? We can just put it there. So the point here is that there's a lot more moving parts. There are a lot more places to get data, but the amount of work happening in each one is smaller, and you've got different teams managing it. So instead of a large monolithic process, you've got a variety of smaller processes. So I want to sort of bring that together in a direct comparison of the two methods. So the old method is highly automated, right? You have an ETL process, it runs every night, it does everything you need to do, and it takes a lot of work to create it and maintain it, but it gets the job done. In the modern analytics framework, you automate as needed. So you don't bring everything into the warehouse because not everything has the same value, and that means you have less development work. You just have less ETL code. So there's less work to do. You only write code like that if you need it, and the code to bring things into like a cleansed data zone or the data lake is going to be a lot smaller because you're doing a lot less. Getting data into a data lake is very easy, and if you need to make a few tweaks to it, that's much less development work than creating a whole fact and dimension star schema. The old method is linear, right? It just goes left to right, source to target, everything comes in. Now we have more moving parts, and that does mean there's more management work. So it means that the data is going to be in multiple places. You want to think about how that is coordinated. You have multiple teams. So it does mean you need to pay more attention to sort of governing and managing the framework. The old method is inflexible. It takes a lot of work to change something, so things tend to change at a slower pace. It's also all bottlenecked through whatever development team is maintaining the warehouse. So it's likely that they have a big backlog of to-do items, and some things, may never get to the top of the priority queue and just sort of sit there and get undone for a very long time. The new modern analytics framework, the whole point of it is to be iterative and dynamic. So you have lots of teams doing lots of things. The level of development for each individual piece of movement is less. So it's very easy to make small changes. We have a new idea. Let's use a data wrangling tool and put it in the sandbox, see how it works. That's a good idea. So maybe we should add that to the batch job that goes to the cleansed data zone or the tabular data zone. Or maybe it's important enough that it goes to the warehouse, but not everything will make that priority. So, and that leads to fresher data, which leads to better solutions. You've got people making changes all the time. You're going to be up to date with requirements. The data is going to be available. People are going to understand where to go to get it. So you're going to get better insights. And that's related to the next line, which is the old method is monolithic. The new method has a lot more diversity. And so that way you can serve multiple audiences. You have data scientists who might want to go back to the data lake. In the past, they had a data warehouse and the data was maybe too cleansed. Because, detail is being lost, fields that weren't important or things were being aggregated. Now they can go to the data lake and get exactly the data they need. Certain types of reports might want to use tabular data, might want to use the warehouse. People can sort of choose the level of detail and the level of refinement that they need. Lastly, the old method was single source of the truth. That was the idea. The warehouse was single source of the truth. Modern analytics framework, it acknowledges that you're going to replicate data to be used for different purposes. You're going to have the same data that might be at different levels of refinement or even different levels of aggregation, depending on what you need it for. And that's because different teams need different things from the data. And that's just an acknowledgement of the fact that there may be one truth, but there's many ways of representing that truth. There's many different angles you want to look at it from, many different viewpoints. And so you want the ability for teams to make changes to put the data in the structure they need it. That does mean, again, that you have to spend time making sure that those things are lined up, that you don't have 4 teams doing the same thing to the data. And that's where the management work comes in. So when you think about this as a whole, you are enabling a broader set of people within your organization to get this work done, to produce analytics. It does mean, with more people is more management, but there's going to be less development work overall to do, and you're going to have more people doing it. So the net result is things are faster, more flexible, more nimble. So when you are bringing in data sources, you end up understanding that data quality becomes increasingly important. The more people that look at your data, the more places your data is being transported, the more problems with the data are going to be noticed. In a warehouse, often you can sort of, you have some business rules, you know what you're doing it for, you can sort of paper over some of the problems, but when people get a look at the raw data, they're going to notice right away, hey, there's an issue here. And so there's many ways to improve your data to increase the quality. You have known issues, you can create business rules. Oh, this field is sometimes null, so maybe we notify someone to fill it in, or maybe we can figure out what the value should be. The data entry team often enters 220 instead of 2020, and so if we see years that are 220, we're just going to assume it's 2020 because we're not doing much business in the early centuries of the era. So creating those business rules, you can just apply those, right? And say, okay, hey, we know this is a way to clean up our data. Let's just do that, put that in the cleansed data zone, and then people don't have to worry about those things. You can bring in third-party data to improve either the accuracy of your data or the breadth of knowledge that you have. So bring in address data or business data or demographic data to increase the number of fields you have about your customers, or bring in address data to make sure that it is more accurate. Is this a valid address? Is this an actual business? And then there's manual review. There's always cases where, hey, I need to go look at some of this data to say, yeah, this is not high quality. And this manual review often happens in the visualization process. I'm making a report, the numbers don't add up, something looks wrong. I go back and look through to discover why, and I discover a data quality issue. So, it's not like all of your data quality should be manual review, but that's going to happen. And there's really no substitute for an expert looking at the data and applying their knowledge to it. So improving data quality is a governance process. There are tools that will help, but it takes analysis and review. Understanding what the problems with your data are is, something of a process. There are subjective aspects to it. What business rules need to get applied is, as an example of that requires an understanding of the business process. Those rules will change over time. Data and its quality, without the apostrophe, will change over time, and so you have to account for that. You may have the perfect set of business rules, but then one of your data sources changes, or your data entry team, starts, using a new method to put some data into a field that maybe they shouldn't, or maybe hadn't been discussed before, and so you have to account for that. So it's you're never going to say I'm done improving my data quality. It's going to be a process, and that is a governance process. Once you have cleansed data, you then have to decide where you're going to put it and where you're going to send it. In the ideal world, you would send this data back to source systems and say, hey, like we noticed there was an address issue. Let's send it back to the source system so the data is completely clean and everyone sees the best version. That's a lot of work. It involves incorporating a lot of teams, so that's not always possible. So at the other end, it may be, hey, we're just going to do it in the warehouse. We're going to cleanse the data, show it in the warehouse. The warehouse is the most refined version. And so if you go there, you can see everything that's as clean as possible. In a modern analytics framework, you probably want to have it go as far upstream as possible. So, maybe the cleanse zone is the place for it, so that all the other zones that are making use of that can get a benefit from the cleansed data. In a warehouse, the sort of old approach, the warehouse was the be-all end-all of where you went. Now, in a modern analytics framework, you want to have a little more flexibility and a little more ability for people to see these changes. So I want to talk about steps that you take in improving data quality. And these are not, you're not going to take all of these steps necessarily, but these are the steps if you were doing a master data management effort that you would take. So the first thing that you want to do is bring the data together and put it in a consistent structure. You would often enrich it with external data here. You can do that later in the process, depending on how your steps work, but this is a good place to start because it gets everything in the right format. So once you have it in a consistent structure, then you can apply your business quality rules. So, if you know certain fields are supposed to be a certain way, or you're checking phone numbers or checking names, things that are going to, I have a rule that says, this field cannot be null, or this field needs to have 4 digits. You can apply those rules. You can mark errors for manual intervention. You can correct those errors if possible, if you know what the answer is. And you create a standard format. So it's very important here. So for example, if you're going to be looking for, address issues, if one person is Main Street, one person is Main ST, it's harder to find that match. If you standardize that abbreviation, it's easy to understand that those two may be the same. And that leads into the next step, which is identifying possible duplicate rows. So, and this is where a tool may be helpful. Computers are very good at saying these two things are exactly the same. They're less good at saying these things may be exactly the same. And so tools like Precisely Spectrum are very good at saying, okay, I'm going to take these two addresses or these two names or these two records which have addresses, names, phones, emails, and give you a confidence score of how likely that they are to be the same. And again, the way that it assigns that score is in part based on the nature of your data and rules that you have created in looking at it, because you may have really good address data and really bad email data, so you want to weigh the address more. Or maybe the other way around, your email data is good, so if 2 records are the same email, the chance that they're the same is extremely high, even if the addresses are totally different. So you create those rules, you apply them, and then it says, okay, here's these two, 99% are the same, 5% are the same, so they're not. I'm not gonna worry about it. But then there are some that'll be in the middle. It's 80% is the same. We probably want to have someone take a look at that and say, okay, let's judge for ourselves. Maybe even look at extra data. Maybe even make a phone call and figure out if those are the same or not. And again, this is something that you do when it's necessary. I'm talking about addresses because for many organizations, understanding your customer base is super important. And so if you have the same person in your system 5 times, it can be very valuable to say, oh wait, this is the same person. Once you've got potential matches, you may have, you've got 5 records that are of the same person. You want to figure out, well, what is the best data I have for each field? Maybe I have 5 records and there's 3 different emails, and which one is the best one? Which phone number is the best? So again, you're going to apply business rules based on your knowledge of your data sources. The phone number in this one is always right. The address, I want to use the one that's most recently entered. Rules like that to create what's called a golden record, and that is, okay, this is the best data that I think I have for this entity. So if someone wants to say, okay, what's the, what address, what phone number, what email should I use for person, or what part number, what description should I use for product? That's where it is. And then what you do is you connect that back to all the source data. So, take those 5 records that came in and say, for these 5 records, here is the golden record. So, and either if you're going to publish this data back, then you can send that information back to those systems and say, hey, please use this data for this entity. Or if you're doing it in the analytic zone, you can say, well, here's, if you're looking at this source system, hey, go look at this master record to get the best data for this person. It makes it easier to link to it and understand it. So usually there'll be a mapping of, source system ID, whatever maps to this master record. So this gives you in the end, a master list of the best possible data for a given entity. And when you do that, what you're doing is, again, you're spending some development time to improve your data quality, which makes the data far more useful to your population knowledge workers, which is going to improve the value of the analytic assets that they generate. So to summarize, a modern analytics framework is more diverse and more complex. It serves more audiences, which lets them generate more insights. So that means that you're going to be performing more management, but less automation work. So, people will work more efficiently in terms of development time, but you do want to keep everyone coordinated. You let multiple teams replicate the data and manage their own processes. So you've got more people doing this work, which means they're going to get it done more efficiently and faster. But it means that data quality and cleansing is increasingly important. So, you are broadening and expanding the amount of work that's taking place, which means you want to manage it and make sure that people are sort of all going in the same direction and not duplicating effort. So that's the summary for today. We're going to go to Q&A. So what questions do we have?
Jeff, it's Paul. Thank you for that. And we do have some questions that have come in. Okay. So here's one. It says, how does a database like Snowflake help with this new approach?
So Snowflake is a cloud architected database that is, I think, takes maximum advantage of the elasticity of the cloud. And that's really helpful. If you think about the sandbox in the new data ingestion diagram, a database like Snowflake is really good because you can expand it as needed if you have new amounts of storage or new amounts of compute. And if you're not using it, you pay very little. If it's very, you have a lot of incentive to put data on there and play around with it, and you're not paying to have a server running or something if you don't use it all the time. So it really helps a diverse population of knowledge workers create the data structuring tools that they need to create analytics.
All right, terrific. Let's see. This one, kind of a two-part question. How important is data quality? And you talked a lot about that, but and related to that is, do I need to master all my data?
That's a good question. Actually, I should have talked about that earlier. So I sort of went into the data mastering part, and the answer is no. You probably don't need to master all your data. The principle to apply is the same one when you're thinking about, do I need to put all the data in the warehouse? You want to think about what is the value to mastering my data versus the trade-off of the effort required to do so. So, for many places, mastering their customer base is super important. But because they want to know, they may be selling 5 different product lines to the same customer and not know it because there's 5 different records. So if that's a value to you, then you want to master that data. But maybe you have some duplications in your product database, but that's not as important. So it's a business value judgment to say whether you master particular data or not.
All right. Okay, here, how does this framework make ingesting new data sources faster? It seems more complicated, more moving parts. How does it make it faster?
It is more moving parts. That's very true. So it makes it faster in a couple of ways. I mean, the first way is that any new data source that comes into existence, the first goal is get it in the data lake. And the whole point of a data lake is that it is easy to put data in. So there should be sort of existing processes and techniques, and then there should be someone whose responsibility is, oh, there's a new data source, I'm going to put it in the data lake, and I'm not going to worry about anything else, but I'm going to make sure it's in the data lake. That's a very easy process. Unlike the sort of old approach where until the data is all the way through in the warehouse, no one sees it. The moment it's in the data lake, people can use it, and so with a much lower barrier, now that data is available. Now, it may be that the warehouse team says, oh yeah, this needs to go in the warehouse, and we're going to start working on it. It may take them a while. In the meantime, other groups can say, okay, well, I'm going to do my own thing. I'm going to pull that data out with a wrangling tool or a script and do some work on it, put it in Sandbox, and make use of it. So the data becomes useful much earlier. And and with each of those analytic zones, the barrier to getting into that zone is a little bit higher, but still lower than getting to a warehouse. So data is going to flow through that structure a lot more quickly and a lot more efficiently if it has value. So by spreading out, by making it easier to put data in and sort of creating the spectrum of sort of development time and ease of ingestion, and broadening the base of people who could do that work, you're making it easier for data to get in and to be available to people.
That's great, thank you. Okay, one has come in. It says, I did not see a data catalog in the new architecture. What role can that play?
That's a very good question. So I didn't put, it wasn't in there because that diagram had a lot in it already. But it was in some of the earlier ones we've talked about. It's in the reference architecture. A data catalog is exactly the kind of tool that you would use to help manage the diversity of data sources and people going after it. So, if you think about the Modern Analytics Framework diagram with the various data structures and data flowing between them, a data catalog is a way to say, to help people understand what is in each zone, what kind of data it is, what level of quality and refinement it's at, so that if they need to go get data, they may say, oh, I need customer data. Well, there's the customer dimension, there's the raw customer data, there's what level of refinement do they need, so they can understand sort of where it is and go get it. Or if a data scientist is about to do something with customer data, they can look in the catalog and say, oh, someone already did that, I'll just go use what they did, as opposed to duplicate their work. So a data catalog and the processes around maintaining it are, I would say, crucial to a modern analytics framework.
That's great. And one last one, I know we're running out of time here. Interesting question. Can I just get rid of my data warehouse and ETL? What happens to the traditional work you've already done in the past with?
So the probably not. We mentioned this in earlier sessions. The data warehouse is valuable, and we'll talk about this next week when we talk about knowledge workers. There are people for whom the data warehouse is the best way to deliver information. If I'm a business user and I want to do drag and drop reporting and create a dashboard or report quickly, the data warehouse is one of the best places for that. The challenge is that it's more work to put data there. So you want to put high value data in the warehouse. And so, generally speaking, most organizations have that kind of knowledge worker population. And so a warehouse makes sense. It's just that you don't want to put all your data there because there's too much work to do that. So there's a balance between, making the data available and justifying the work required to do that. So, you probably, if people have a warehouse now, probably there are things in it that are high value, and there are probably things in it that are lower value. And so understanding that and saying, well, this piece, maybe we're going to just shift that down to a tabular zone because we don't need to maintain it in a warehouse because it's not valuable enough. That's the kind of analysis and decision making that you want to do when you're thinking about how you want to support your data framework.
Got it. All right. Well, Jeff, I think we're out of time. Do you have any closing remarks? Or?
Yeah, I'm just gonna switch forward to we've got this 6-week series coming up, so we've got a few more weeks going, and so I hope to see you again on future Tuesdays. but we also have a bunch of Thursday topics coming up, including an industry focus on insurance this week. We just added some September topics as well. I don't have them on this slide, but you can go to our website, and you can also go there if you want to ask some questions of a data scientist, a BI expert, a data advisor, and have a more one-on-one conversation. So I invite you to do that and sign up to spend some time with one of us. I think that's what I have. Unless you've got anything else that I missed, Debbie, we are all set. Thanks, everyone.
Sounds great. Thanks. Have a great day.
Thank you, everybody.